Oh, good morning, everybody. Happy Tuesday. So if you have not finished the test, if you have not even got it into me yet, you need to get the test in. Test. I haven't seen the test. You're going to get a 0, and that's really going to hurt your grade. So please get it in. The end of the quarter is coming at the end of this month. Actually, maybe only a couple of weeks left for the quarter. So if your grades are looking bad, get it fixed, okay? Anyway, today, what we want to do is talk about graphing parabolas. These are easy. Really, these are easy. Graphing parabolas. So parabolas kind of look like this. I'll show you. They look like a smiley face. Well, or they could even be like a frowny face, but this is kind of what a parabola looks like. This is a really rough sketch of a parabola. That's a parabola. So let's figure out how we do it. So little t-table, so we can get the general feel of what a parabola is. Like a t-tables are like this. They're called t-tables because it looks like a T. X and Y, and if I let these be my X values, 0, 1, 2, 3, -1, -2, -3, and we're going to plug these numbers into an x squared. So that's easy. Okay, so x squared is like 0 times 0, or, yeah, 0 times 0 is 0. Plug in 1. 1 times 1 is 1. We'll plug in 2. 2 times 2, or 2 squared, is 4. Plug in 3. 3 squared, or 3 times 3 is 9. Now, a negative times a negative is a positive. A negative times a negative is a positive, so -1 squared is a positive 1. A -2 squared is a positive 4. And a -3 squared, -3 times -3 is a positive 9. Now, these create points. The t-table makes points. Point is 0, 0. Well, that's easy. Let me get my little marker out here. Hold on. Okay, these are points. I'm going to try and make a graph. Makes it look like a point. Okay, there we go. So I'm going to go 0, 0. That's right about there. Now let me get a different color. I like the pink one. There we go. 0, 0. There we go. And then this is a point like 1, 1. This is a point at 2, 4, 3, 9, -1, 1. These are points. That's what a t-table helps us make. -2, 4, and a -3, 9. Okay, these are points. And then I'm going to graph them. 0, 0, 1 over 1, up 1. 2 fourths over 2, up 1, 2, 3, 4. Over 3, 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And it keeps going. 4, 16, woo, way up there. 5, 25, woo, way up there. But let's do the negatives. -1, 1. -2, back 2 and up 1, 2, 3, 4. -3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's what my parent function looks like. We call it a parent function because it's the most basic. Okay, and then so that's my parent function. Okay, it's the most basic function. Okay, so then what we want to do is take this and graph y equals 2x squared. So what we're going to do is we're going to make it twice as tall. So if we did a t-table, we'd get these points. Do a 0, 0. We'd get a 1, 2, because we're going to make it twice as tall. So we're going to multiply all of the y values by 2. So I'd get a point at 2, 8. I'd have 3, 18, which is going to be off my graph, right? I'd have a -1, twice as tall, 2, -2, 8, twice as tall, and then a -3, 18. Okay, so I'm not going to be able to graph all of these points because it's going to be just too tall, but it's going to look like this. It's going to be the same shape, just much skinnier or taller. So I'll graph these points. 0, 0, 1, 1, 2, 2, 1, 2, 3, 4, 5, 6, 7, 8. 3 18s off my paper. So, and another thing I noticed, they're symmetrical. See how this, I know there's got to be a point there, but that's my -1, 2. I know there's got to be a point. See the symmetry? Right there. And then even higher. So this is this twice as tall. It's my parent function, but it's a vertical. This is a vertical stretch of 2. All right. Same shape, same parabola, except for it's a vertical stretch. It's twice as tall. Okay, now let's keep moving on this. So if we take a look at number 1, okay, that's our parent function. Hopefully we can do this in our head by now. So my parent function, I just do in my head because I know how to do it in my head because I'm smart and so are you. So let's see. We don't need a t-table. Watch, I'll go through this slowly. Watch. Right here, 0. Okay, 0 times 0 is 0. Okay, move over 1. 1 times 1. 1 times 1 is 1. Okay, move over 1, 2. See, I did that for the vertex. That's the vertex. 1, 2. 2 times 2 is 1, 2, 3, 4. See, I'm doing this? And then move over 1, 2, 3. 3 times 3, or 3 squared, is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I can just flip it over to the other side because there's this thing called a line of symmetry, which we're going to talk about more later. But right down the middle of this thing, it flips. It's a line of symmetry. I see symmetry. So if I flip this point over the line of symmetry, flip this point over the line of symmetry, flip this point over the line of symmetry, I get a parabola that looks like that. Okay. All right, number 2. 0.5, so it's going to be half as tall, okay? So this is going to be a vertical shrink. A 0.5. And watch how I do this, because I don't want to do a t-table. I'm just going to be smart and use my brain, which you can too. It's really not that difficult. You can do it. I know you can. So let's take a look at, you ready? Think this through. 0. 0, 0 is 0, but half as tall as 0 is still 0. Now, 1. 1 squared is 1, but half as tall, so I'll go to 1 half. Okay, so I'm taking half of these heights. Half of these heights are 0.5. 2, and normally I'm 4, but now half as tall, so I'm 1, 2. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, but taking half that height, so I'm going to 4.5. Now I know it's symmetrical because I have a line of symmetry right down the middle. And then I'm going to go ahead and put that in. So I flip these over here, here, and here. So here is my parabola, but it's half as tall. Now 3, we already did 3. We did 3 over here. I don't need to do it anymore, but you can see it's a vertical stretch. This is a vertical stretch. How about 4? We'll do slide 4 over here. Looks like I've got my darn paper off. 4 over here. So negative x. It just means that it's going to be upside down. Upside down, or it's reflection over the x-axis, okay? So let me go ahead and to do that, I'm going to put in my xy axis here, my pen, but I'm going to put it way up here because I know it's going to be upside down. So I'm going to put my x-axis up here, my y here, because I know it's going to be a flip, it's going to be upside down. So instead of this shape here, that's my parent function, I'm just going to have this whole thing flip down here. So instead of being like here, this negative is going to make this graph upside down. So I'll do the same thing. 0, 0, go 1, 1, but upside down. 1, 1, 2, 4, because 2 squared is 4, but upside down. 1, 2, 3, 4. 1, 2, 3, 3 squared. 3 squared is 9, right? 3 squared is 9, but upside down. 1, 2, 3, 4, 5, 6, 7, 8, 9. I know it's symmetrical, right? There's my line of symmetry. And I can just flip it over the line of symmetry. Okay, there it is. Okay, number 5. So number 5 is going to be my parent function x squared. That's this one, except for I'm going to bring it down 4. I'm going to take the whole thing, slide it down 4. So I'm going to do the same process, except for I'm going to take this parent function and bring it down 1, 2, 3, 4. So I think I'm going to put in my xy axis, make sure I have like -4 there, so I want to make sure I have room for it, so I made my axis so I could go down to 4. So let's take this whole thing, this whole entire parent function, we'll do a I'm going to do a translation, so we're going to do a shift down, so we're going to do a vertical, shift down 4. Okay, I'm going to do that. So again, take my parent function, this one right here, and bring it down 4. So 1, 2, 3, 4, and the exact same shape. So here we go. You ready? Remember we do this 1 squared is 1. Go back, I go over 1, 2, 2 squared is 4, 2, 3, 4, 3 squared, 1, 2, 3, 3 squared is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course it is symmetrical over the line of symmetry, which is right there. We can flip these here and to here and to here. Okay. Now, one last thing. I don't want to disregard technology, because we can, of course, do this stuff on Desmos. And I don't know if you guys like Desmos, but Desmos will, of course, do it. So let me take a look at some of these, okay, so you can see it. Okay, so if I have a y equals x squared, there it is. Here's my parent function. If I had a y equals a negative, let's do 0.5. 0.5 x squared. See, it's a little bit, it's not as tall, it's stretched out. If I had a y equals a 2x squared, there it is, it's just much taller. Okay, see that? And then even if I do this one, if I have a y equals x squared, subtract 4, there it is, drop down 4. Okay, anyway, pretty easy lesson. I can do these either on Desmos or in my head. My brain is fast enough to do it because I can do this, and so can you. Okay, that's all I have. Hopefully you've got your test into me. If you do not have your test into me, then that's not good. Okay, that's all I got.